Welcome pre-cal students to class today on this Thursday the 27th. Hopefully we get this video up and running now. Sorry about the delay. Hopefully you got my email and we'll see if we can't get this thing going now. That's the second time this year we've had some problems, so I don't see it being an issue. And here we go. There will be a quiz this Saturday, so be ready for that. I've already got it ready for you. I just need to email it to you. It'll be out of the book like it is so often. And look for more details on that coming in Friday's video, tomorrow's video. But there will be a quiz on Saturday. Stay on top of your integrity sheets. They are called integrity sheets for a reason. You are to be men of integrity and be honest about the homework you have done or not done. And then don't forget to turn in your tests. They were due yesterday, so make sure you're finishing all of that. Okay, continuing on. I don't want you to be scared or worried, but I do want you to understand that today's math is challenging. Should have a period there. Function word problems are one of my favorite types of word problems. They're really like a puzzle. And today's math might take an hour or even two, and that happens sometimes. Remember, yesterday's math was not as difficult. So I try to be balanced in this area. Today's video I'm going to give you in teaching you the math is pretty short. It's just 2 word problems and we're finished. But the homework is only 6 problems long. But you're going to be challenged. You're probably going to have to back up a lot of the video problems and watch them again and rethink everything. This is going to be a total different way of teaching or making your mind work in a certain way. And so it could take an hour, it could take 2. That doesn't happen very often in this class. So, don't be upset about that. And with a great attitude, let's man up, let's work hard, and see if we can't comprehend some difficult math today. Sometimes students will hear a teacher say the math's going to be hard, and they're like, oh, good, man, I've got an excuse now. I can tell my parents or whatever, hey, it was just really hard. Then there are some students who say, hey, I'm going to work really hard and actually understand this math. And I hope that's the attitude you'll take. Here's your heading for today, Caleb Matthew, Function Word Problems, Lesson 1.5. And the date today, if you would like to write that down, is the 27th of February, 2014. Function Word Problems, Lesson 1.5. Now, I'd like you to turn your books to page 122 and look at example 3. Please turn to page 122, look at example 3, and you need to pause the video as much as you feel necessary throughout this video. I'm going to go ahead and start reading the problem. It reads at the bottom of the page as follows. Tracy and Graham drive away from a campground at right angles to each other. Tracy's speed is 65, Graham's is 55. Letter A. Express the distance between the cars as a function of time. Now, students, we need to talk about something, okay? We need to talk about this phrase right here. Please write this down. What does it mean when it says write distance as a function of time? Well, can I show you, please? What does it mean when it says write distance as a function of time? Whenever you're writing something as a function of something, now, I know that's not very good teaching, but listen, whenever you're writing something as a function of something, your first something, in other words, in this case it's distance, is the unknown that goes all by itself. And then over here you'll have numbers and positives and negatives and exponents or whatever, and you'll have one variable over here, and that'll be t. Let me give you an example. I think this example will make sense. When it says write distance as a function of time, they want you to write an equation. I'm just making this up. There. That would be distance as a function of time. Okay? Because notice I have d all by itself, and that's your first something. And then notice this is so important, notice you have no unknowns over here, none except for t. And t stands for what? Time. You cannot have any other unknowns over here like an x or something else. It has to be d here and t over here. Now, one more thing I would like you to get used to doing is this. I'm going to make this mandatory, so I will take a point off on your test if you don't do this. I would like you to write it in functional notation. So you would really say, let me make that a little neater. You would say d of t. d of t equals this right here. So that means d of t means distance based on time equals this right here. So in other words, I can put in a variable for t, which is time, and when I solve this, I will get out a distance. So that's what the phrase means when it says write distance as a function of time. Write distance as a function of time. Your first something is distance, so that's going to be your unknown right here, and your second something is time, and that's going to be your only variable over here, t. And here we have a function, distance as a function of time. Okay, let's go ahead and try to solve this problem. So now that you know what our goal is, it would probably be very beneficial if we got a picture of this problem. So let's get a picture of the problem. These two leave a campground at a 90-degree angle. So here's my right triangle. I'm going to make one leg a little longer than the other because one person is traveling faster than the other. Now, excuse me, we have Tracy and Graham, I believe are the two names. And so I'm going to put T right here for Tracy, and parentheses, well, I better put TR so you don't think that's time. Tracy, and the speed of Tracy is 65 miles an hour. Here's Graham, and Graham is traveling at a speed of 55 miles an hour. Now, I'm not sure when they're going to stop. We're just going to put a dot here, and we're going to put a dot here. Now, if you'll go back to the problem and listen to this carefully, see if this makes sense. Letter A says, express the distance, listen, between the cars. So really, you're trying to find this distance right here. You're trying to find the distance between the cars as a function of time. So in other words, think about it. Does this make sense? As time goes on, the cars will get further apart, right? I mean, in 1 hour, they're going 55 miles an hour, right? So in 1 hour, Graham's gone 55, Tracy's gone 65, and then they're a certain distance apart. Well, in 2 hours, Tracy will be up here somewhere, Graham will be out here somewhere, and notice their distance is even further. So you do understand, as time increases, 1 hour, 2 hours, 3 hours, 4 hours, the distance between the cars will also increase. Now, I've not said anything profound so far, and I think everything I've said, hopefully you can understand. I mean, it said they left the campground. Here's the campground right here. We'll put a C right here. And they left at a 90-degree angle. So we'll say one went north and one went east, okay? Sorry, excuse me. So there's a really good picture of what we're looking at. Now, normally, see if this makes sense, okay? I'm going to call this distance number 1, and I'm going to call this right here distance number 2, okay? Now, over here, we'll call this, I don't know, I guess we'll call it distance number 3 for lack of a better word. Do we not know a formula for these different distances? Don't we have a right triangle? We do, don't we? So think about this, please, guys. Try to write a formula that would give you this distance right here. Remember Pythagorean's theorem? Watch this. L squared, now watch this carefully. L squared plus L squared equals 8 squared, right? And if you want to find the hypotenuse, you could take the square root of both sides. We've learned this in the past. We've done this before with vectors. Take the square root of both sides, and now you know what the hypotenuse equals. The hypotenuse equals the square root of your two legs being squared and added together. So there's not this right here. Is not this the square root of a right triangle? Sure it is. So if I want to find this distance, we'll call it distance subscript 3. If I want to find this distance, would I not use this model right here? Look at this right here. The hypotenuse equals the square root of the sum of the legs squared. So the square root of distance 1 squared plus distance 2 squared. Now that's not even close to what we need. You understand that? That's not even close to what we need. I mean, think about this. We're supposed to write distance as a function of time. So in other words, we want to have d over here. And we've got d, that's fine. But over here we should have t's. We should have t's everywhere, and we don't. So somehow we're going to have to rewrite D1 so that it has a t, and somehow we're going to have to rewrite D2 so that it has a t. Now again, I'm not asking you to teach the class, men. I'm not asking you to give a speech on this, but that should make a little bit of sense. You might not know how to do it, but it should make sense what we're trying to do here. First of all, I realized I want distance as a function of time, so D equals some stuff over here with t. Second of all, I then drew a diagram of what the problem expresses or describes. And then I wrote a model that would give me my distance. But the problem is the model doesn't have t's over here. So somehow I'm going to have to get rid of these d's and make them t's. Well, I have an idea. Remember back in middle school math, rate times time equals distance. That should make sense, guys. Come on. If you're traveling 20 miles an hour and you do that for 2 hours, isn't that 40 miles? Think about it. You're going 20 miles an hour. That means 20 miles every hour, and you do that for 2 hours, you get 40 miles. So there is a formula that says distance is the same thing as rate times time. Distance is the same thing. It equals rate times time. So if that's true, which it is, then for my distance right here, I'm going to go ahead and put rate times time. I just showed you how distance equals rate times time. And so for my distance right here, I can also put rate times time. Oh, hold it. I know my rate for Tracy. My rate is 65. So instead of putting an R here, I really have 65 T. So look what I did there. And right here, same thing. See this R? I know Graham's rate. Graham's rate is 55. So really, I can put 55T right here. Let's go over this again. Distance equals RT. So instead of having a D here for distance, I put RT. Instead of having a D here for distance, I put RT. And then for R, I can put 55 because the rate is 55. For my R, I can put 65 because 65 is my rate. So now, if I can get out an eraser here and hopefully erase, well, it's going to be hard to do. Let's try to take this to another page. That's not going to work either. Okay, that's fine. So what I have here is now my whole distance right here is really 65T. And my whole distance right here is really 55T. So, and by the way, Mr. Earhart, why didn't you put anything in for D? Well, guys, D3 is right here, right? And remember, we're trying to write distance as a function of time. What do I want over here all by itself? I want D, distance, and I've got a D. You could put RT for distance, but that's not going to help you because you want a D over here. You do not want D's over here. What do you want over here? Remember, you want T's. So look what I can put. Instead of putting a D right here, a D squared, look what I'm going to put. I'm going to put distance equals, what about the 3, Mr. Art? Well, I'm not worried about the 3 now because I don't have any more D's over here, so there's only one D. What am I going to put for distance 1? Well, I'm going to put 65T. And what am I going to put for distance 2? 55T. I did it. Look what I have. I now have a D over here and I have all T's over here. Now the only problem, of course, like any normal pre-calculus class, you're going to want to simplify that. So let me get a new page here and let's do some work on this and let's simplify it quickly. I've already got the work done. I'm not going to spend a lot of time on this, but D equals 65T squared is 4,225. T squared plus 55T squared would be 3,025 T squared. And now we have like terms under the radical, so we can add those two terms together. When you add your two T squared terms together, you get 7,250 T squared. Now this is one term. If there was a plus sign here, then you could not take the square root of both of these. But whenever you have just one term, you can go ahead and take the square root of your coefficient and your variable. So the square root of 7,250 is 85.15, and that's rounded and that's sufficient. And the square root of T squared is T. I'll just put a little t. T. So what do I put over here? Remember, in your final answer, I don't want you to put D. I want you to put D of t. There you go. You did it. You just wrote a function of distance based on time. So you can give me any time that you want to, 1 hour, 2 hour, 3 hour, 4 hour, and out will pop the distance between the two cars. That is cool. Very cool. Okay, so there we go. We have a distance based on time. Hey, I want to know how far those cars were from each other. 3 hours. Okay, put a 3 right here. 85.15 times 3, you'll get your answer. Okay, and so there we go. Of course, the time is in hours and the distance is in miles. How do I know that? Because we were dealing with miles per hour. Miles per hour. So the whole problem is in miles and hours. Now, question B says, find the domain of the function. Now, normally when you look at a function like this, the domain, of course, is the variable over here. And you say, well, the domain is all real numbers. T can be anything. Hold it, hold it, hold it. T is referring to time, correct? So if T is referring to time, there's no way you can have negative time. You can't say they left -3 hours ago. So the domain is T has to be greater than what? 0. Not equal to. That's my fault. It should not say equal. Well, I guess it could be equal. I'm not sure what the book has. I'm going to go ahead and put equals because you can have a 0 of time. I mean, if you put a 0 in for T and there's been 0 hours, how far away are they from each other? 0 miles. They haven't left yet. So, in my opinion, you can definitely have 0 for time. So your domain is T is greater than 0. That's your domain. So you have to interpret the domain based on the word problem itself. And T refers to time, and time cannot be negative. Okay? Let me get a drink and we'll go on to one more word problem. Okay, please turn over to page 123. Let's look at example number 4. Example number 4. The sound shop has 20 feet of dividers, and they're going to use this to set off a rectangular area for storage. They're going to use a corner of the store. So in this way, they only have to use 2 partitions. In other words, here's the entire store, and right here in the corner, they're going to put their storage area right here. So they only need 2 partitions. Do you see what I'm saying? They already have a natural wall here and a natural wall here, so they can use all 20 feet of their partition right here. Now, if they were to put their storage area right in the middle of the room like this, right here, then they couldn't have as big of an area because they would have to split up their 20 feet of partitions into 4 walls. 1, 2, 3, and 4. So they're going to put their storage partitions in the corner of the room like this. So there's a good picture of it. Now let's read letter A. Express the area as a function of the length of the partition. Okay, no problem. Let me go forward a page and let's go ahead and drag this beautiful drawing. Of course, I'm being sarcastic. Let's drag this to the next page here if we're able to do that. And maybe we're not, and that's okay, no big deal. Alright, here we go. So if you'll look at letter A in your book, letter A says write the area as a function of the length. So what does that mean? That means you're going to have area equals, and you're going to have some formula with an L over here. So your final answer will look like this: A of L equals, and then you'll have numbers and all kinds of stuff, and the only variable you'll have over here will be an L. Isn't that easy? Look guys, something as a function of something, area as a function of the length. Your first something is area, so that's going to be all by itself over here, A, and then as a function of L, so your L will be over here. It's just that simple. In fact, I'm going to go ahead and get rid of this function notation to the very end. I feel like that could be really confusing, so I'm going to get rid of that notation, and I'm just going to simply say, here we go. Area as a function, so your A goes here. Area as a function of length, so your L goes right here. So here we go. Let's go ahead and get started. Now, first of all, we need to come up with a formula like we did in the last problem. The last problem we used Pythagorean's theorem, remember? And we said L squared plus L squared equals H squared, and we took that formula and we wrote a function. And that function wasn't good enough because we didn't have T's over here. So we then had to make substitutions for D and make your D's become T's. So let me get a drink here real quick. It's going to be the exact same thing here. We have to come up with a formula for area. Well, I have it. We're trying to find the area of a rectangle right here. Very sorry, guys, about the coughing. Sorry. I wish I could shake this thing. So this is your length and this is your width. So the area of the storage room is length times width. Isn't that true? You guys know how to find the area of a rectangle. So the area of the rectangle, which is what you want to write a function of, area as a function of length, area is length times width. Now you want to have in your final answer an A over here and only L's over here. And look what you have right here. You've got a W, and that W has got to go. So somehow we're going to have to think of a way to make a substitution for W. Okay? Well, students, think this through here. Come on. We know I have 20 total feet of partitions, right? So I'm not sure how long this side is, and I'm not sure how long this side is, but I know if I add those two sides together, L plus W, I know it has to equal what? 20. I mean, I'm assuming I'm going to use all the partitions because I want as much storage space as possible. So this is true. All of my length here plus all of my length here is 20. Now, if I take this, remember, I want to get rid of W. I want to try to think of something that W equals. Well, bring your L over and make it a negative L, and you're left with 20 minus L. Look at that. So now you know what W equals. W equals 20 minus L. So now for W, I'm going to put 20 minus L. There we go. And now multiply your L through, and I think we've done it. L times 20 is 20L. L times a negative L is negative L squared. So you did it. You wrote the area as a function of L. You have an A here, and you have all L's over here, except for the numbers, of course. So remember how to write it. We write it in functional notation. A of L equals 20L minus L squared. There. Part A is finished just like that. Now letter B says, find the domain of the function. Okay, no big deal. Here's your function. Your domain refers to L. Now normally you would say L is all real numbers because really L can be anything. But hold it. L is referring to the length. Now come on, think about this. There's no way your length can be negative, right? So we know your length has to be greater than what? 0. So you think you're finished, but hold it. You only had how many total feet of partition? 20. So we know your length has to be less than what? 20. Think about it. I mean, if you wanted to, you could make your storage area 19 feet, 11 inches long if you wanted to. And then this could be 1 inch. That's totally fine. I mean, it'd be weird. It wouldn't be very smart, but you could do that. But your length could never go over what? 20. Because you only have how much total partitions to use? 20 feet. So the domain of this problem for L has to be greater than 0, but it also has to be less than 20. So you'd write it like this. You put L in the middle. You put your smaller number over here, your larger number over here, and you point your arrows to the left like we've done before when dealing with domain. And there you go. L is greater than 0, not equal to. There's no way you can have a length of 0. And by the way, there's no way you can have a length of 20. It's not, it's not equal to. Sorry. Because if you have a length of 20, then you have nothing left for your width. All you have is just a straight line right here. So it cannot be 20 and it cannot be 0. So L has to be greater than 0, less than 20, non-inclusive. Now we're almost finished. Let's take a look at the graph they give you. And I should have cut and pasted this into the video. I'm sorry that I didn't. They give you a video that, or excuse me, they give you a graph that looks like this. And let's see here. Starts here and goes like this. Okay? And this point right here is 10, 100. Now, can we think about this for a second, please? Here's your model, your function. A of L equals 20L minus L squared. Now think about this. L, just like in a normal function, L would be your axis, so we're going to call this your L axis. Area is all by itself over here, which is usually your Y, so we're going to call this here my Y axis, be my A axis. So that means this 10 would be going over 10. So we're going over 10 and we're going up 100, right? So this 10 is referring to the L axis going over 10, right? This 100 is going up referring to the A axis. So could you interpret that ordered pair? It means when your length is what? Come on, L refers to 10. When your length is what? 10 feet. What does A stand for? The area will be what? 100. Now, look at letter C. Using the graph at the left, determine the dimensions that maximize the area. In other words, maximize means gives the biggest area. Well, is not this the highest point on the graph? Yes, it is. Does it go any higher than this right here? No. So what's the highest value on your A-axis you're going to go to? 100. So what's your greatest area? 100. So if 100 is your greatest area, what length gave you that greatest area? 10. So there's your dimensions. Here's your rectangle. So you have a total of 20 feet to be used. So if your length, let's go back a page. If your length right here is 10, then your width must also be what? 10. So question C says, determine the dimensions that give you the biggest area. Well, the biggest area is 100 and the length is 10. So the best dimensions you can use would be 10 by 10. Or length is 10 and width is 10. Now guys, look, I don't think I've said anything that you're sitting there scratching your head saying, wow, I'm lost. I think you probably understood 99% of what I said. The key, though, is are you able to take a problem at the very beginning and think of all of this on your own? The answer is probably no, you're not quite ready to do that. And so we're going to practice 6 problems. Now, my advice to you is to probably watch the video. And earlier in this video, I said today's work might take an hour or two. You might want to watch the homework video and do them, and then, as crazy as this sounds, not watch the video and try to do all 6 again on your own without any help, because that will really show you where you're at in your understanding of this. Or you might want to try the 6 problems on your own and see how you do, and then if you get stuck, turn the video on. That's totally up to you, okay? If you have any questions, call or email. That's it for today, and now the homework is right here, and that's going to be due right away. Work on your homework right away and get it done. And again, if you have any questions, call or email.